How to use the parse statement. I am in the process of learning Python and I have reached the section about the parse statement. The guide I'm using defines it as being a null statement that is commonly used as a placeholder. I still don't fully understand what that means though. What would be a simple / basic situation where the parse statement would be used and why would it be needed?
Suppose you are designing a new class with some methods that you don't want to implement yet. If you were to leave out the parse, the code wouldn't run. You would then get an To summarize, the parse statement does nothing particular, but it can act as a placeholder, as demonstrated here. Python has the syntactical requirement that code blocks, after if, except, def, class etc., cannot be empty. Empty code blocks are however useful in a variety of different contexts, such as in examples below, which are the most frequent use cases I have seen. Therefore, if nothing is supposed to happen in a code block, a parse is needed for such a block to not produce an indentation error. Alternatively, any statement, including just a term to be evaluated, like the ellipsis literal ... or a string, most often a docstring, can be used, but the parse makes clear that indeed nothing is supposed to happen, and does not need to be actually evaluated and, at least temporarily, stored in memory. Ignoring all or a certain type of exception, example from XML. Note, ignoring all types of raises, as in the following example from Pandas, is generally considered bad practice, because it also catches exceptions that should probably be passed on to the caller, for example keyboard interrupt or system exit, or even hardware SUMPHI error. How do you know you aren't running on a custom box with specific errors defined, which some calling application would want to know about? Instead, using at least except error column or in this case preferably except error column is considered much better practice. A quick analysis of all Python modules I have installed gave me that more than 10% of all except ... column parse statements catch all exceptions, so it's still a frequent pattern in Python programming. Deriving an exception class that does not add new behavior, for example, in SciPy. Similarly, classes intended as abstract base class often have an explicit empty _init_ or other methods that subclasses are supposed to derive, for example, Pebble. Testing that code runs properly for a few test values, without caring about the results, from birth. In class or function definitions, often a docstring is already in place as the obligatory statement to be executed as the only thing in the block. In such cases, the block may contain parse in addition to the docstring in order to say this is indeed intended to do nothing, for example in Pebble. In some cases, parse is used as a placeholder to say this method /class /if block / has not been implemented yet, but this will be the place to do it, although I personally prefer the ellipsis literal ... in order to strictly differentiate between this and the intentional no-op in the previous example. Note that the ellipsis literal is a valid expression only in Python 3. For example, if I write a model in broad strokes, I might write where others might have before. As a reminder to fill in the update_agent function at a later point, but run some tests already to see if the rest of the code behaves as intended. A third option for this case is raise not implemented error. This is useful in particular for two cases: either this abstract method should be implemented by every subclass, and there isn't a generic way to define it in this base class, or this function, with this name, is not yet implemented in this release, but this is what its signature will look like.
Besides its use as a placeholder for unimplemented functions, pass can be useful in filling out an if-else statement. Explicit is better than implicit. Of course, in this case, one would probably use return instead of assignment, but in cases where mutation is desired, this works best. The use of pass here is especially useful to warn future maintainers, including yourself, not to put redundant steps outside of the conditional statements. In the example above, flag is set in the two specifically mentioned cases, but not in the else case. Without using pass, a future programmer might move flag equals true to outside the condition, thus setting flag in all cases. Another case is with the boilerplate function often seen at the bottom of a file. In some files, it might be nice to leave that there with pass to allow for easier editing later, and to make explicit that nothing is expected to happen when the file is run on its own. Finally, as mentioned in other answers, it can be useful to do nothing when an exception is caught.
The best and most accurate way to think of pass is as a way to explicitly tell the interpreter to do nothing. In the same way, the following code means if I called the function foo x, y, sum the two numbers the labels x and y represent and hand back the result. Means if I call the function bar, do absolutely nothing. The other answers are quite correct, but it's also useful for a few things that don't involve placeholding. For example, in a bit of code I worked on just recently, it was necessary to divide two variables, and it was possible for the divisor to be 0. Will, obviously, produce a zero division error if b is 0. In this particular situation, leaving c as 0 was the desired behavior in the case that b was 0, so I used the following code. Another, less standard usage is as a handy place to put a breakpoint for your debugger. For example, I wanted a bit of code to break into the debugger on the 20th iteration of A4 in statement. So, with the breakpoint on pass,
If you want to hear me